Hello everyone, this is Sarvahita, Assistant Professor of MCA Department from Rohini College of Engineering and Technology. I'm here to discuss a few topics of the subject MC 4102 Object Oriented Software Engineering. We are here to discuss the topic Object Oriented Analysis and Object Oriented Design. First, let us see what is object oriented analysis. In the system analysis or the object oriented analysis phase of software development, the system requirements are determined, the classes are identified, and the relationship among the classes are identified. The three analysis techniques that are used in conjunction with each other for the object oriented analysis are object modeling, dynamic modeling, and functional modeling. Object modeling, it develops the static structure of the software system in terms of objects. It identifies the objects, the classes into which the objects can be grouped into, and the relationship between the objects. It also identifies the main attributes and operations that characterize each class. The process of object modeling can be visualized in the following steps. Identify objects and group into classes. Identify the relationships among classes. Create the user object model diagram. Define the user object attributes. Define the operations that should be performed on the classes and review glossary. Dynamic modeling. After the static behavior of the system is analyzed, its behavior with respect to the time and external changes needs to be examined. This is the purpose of dynamic modeling. The dynamic modeling can be defined as a way of describing how an individual object responds to the events, either internal events triggered by other objects or external events triggered by the outside world. The process of dynamic modeling can be visualized in the following steps. Identify the states of each object, identify the events, and analyze the applicability of actions. Construct the dynamic model diagram comprising of state transition diagrams. Express each state in terms of object attributes. Validate the state transition diagrams drawn. Functional modeling. Functional modeling is the final component of object-oriented analysis. The functional model shows the processes that are performed within an object and how the data changes as it moves between the methods. It specifies the meaning of the operations of the object modeling and the actions of dynamic modeling. The functional model corresponds to the data flow diagram of traditional structured analysis. The process of functional modeling can be visualized in the following steps. Identify all the inputs and outputs. Construct data flow diagrams showing functional dependencies. State the purpose of each function. Identify the constraints. Specify the optimization criteria. Code evidence method. The code evidence mentioned 7 key motivations and benefits in favor of the OOA, that is object oriented analysis and object oriented design, instead of using the traditional analysis methods. These motivations and benefits are: tackle more challenging problem domains, improve the analyst and problem domain expert interaction, increase the internal consistency across the analysis, design, and programming, explicitly represent the commonality between the classes and objects, build the specifications to change, reuse OOA, OOD, and OOP results, provide a consistent underlying representation for the analysis, design, and programming. According to Code and Odin, the main result of object-oriented analysis and design comes from the reduction of complexity of a problem and the system's responsibilities with it. The OOA and OOD method is based on a number of general principles for managing the complexity. According to Code and Yoden, the object-oriented approach is the only way to provide all these principles. The object-oriented approach is based on a uniform underlying representation, that is classes and objects, which according to Code and Yoden leads to a number of major implications. No major difference between analysis and design notations, no transition from analysis to design, no waterfall model has to be followed, spiral and incremental are also possible. They are still have different skills and strategies needed for the analysts and designers. There is a uniform representation from OOA to OOD to OOP. Object-oriented design. It is a process of creating a software system or application utilizing an object-oriented paradigm. This technique permits the creation of a software solution based on object notation. OOD is an implementation of the object-oriented programming paradigm OOP. What is object-oriented design? It is a method the system is considered as a collection of objects, that is entities. The state is shared among the objects and each object is responsible for its own state data. Tasks designed for a specific purpose cannot refer to or update data from other objects. Objects have internal data that represents their current state. Similar objects form a class, and in other words, every object belongs to a class. Objects are all the entities involved in the solution design. Persons, banks, companies, and users are all the examples of objects. Every object has some properties associated with it, along with some methods for performing the operations on those attributes. Class. Classes are generic descriptions of objects. An object is a class instance. A class defines all the properties an object can have and the methods that represent the object functionality. Messages. Objects communicate by passing the messages. Messages contain the target object's integrity, the name of the requested operation, and any other action required to complete the function. Messages are frequently implemented through the procedure or the function calls. Abstraction. Abstraction is used in object-oriented design to deal with the complexity. Abstraction is the removal of an unnecessary and the application of the necessary things. Encapsulation. It is also known as information concealing. The process and the data are tied to a single unit, and encapsulation not only groups together an object's vital information but also restricts the access to the data on operations from the outside world. Inheritance. OOD allows the similar classes to be stacked hierarchically, with lower or the subclasses being able to import, implement, and reuse the variables and functions from their immediate superclass. So this characteristic is known as inheritance. This facilitates the definition of specialized classes as well as the creation of generic classes. Polymorphism. OOD languages give a technique for assigning the same name to the methods that perform similar functions but differ in arguments. This is referred to as polymorphism, and it allows a single interface to perform functions for multiple types. Stages of object-oriented design. The object-oriented design process includes two main stages, that is the system design and the object design. System design means the entire architecture of the internet system is designed at this stage, and it is envisioned as a collection of interacting subsystems, each comprising hierarchy of interacting objects classified into classes. Object design. The design model is created in this phase based on these models created in the system analysis phase and the architecture built in the system design phase. Design of object. Object design process comprise of the following tasks: object recognition, object representation or the creation of design models, operation classification, design of algorithms, relationship design, control implementation for external interactions, modularized classes and connections. The Booch methodology. It is widely used object oriented that helps in the design of system using the object paradigm. This methodology covers analysis and design phases of system development. Booch sometimes is criticized for the large set of symbols, and this method has the following diagrams: class diagrams, object diagrams, state transition diagrams, module diagrams, process diagrams, interaction diagrams. So this is a Booch notation example. Thank you.